we're just at the top of the hour. There's still people coming in, but we're going to go ahead and get started. So if you're just joining us, welcome. We're just kind of kicking off here. This is AI in Action. This is part of our Marketing AI Conference event series. It's a pre-event series. So Marketing AI Conference is coming up on September 13th and 14th. It's a virtual event. So you haven't missed out on the chance to join us there. We'll share some more information in our promo code a little later on. But this is our free 6-part series leading up to the event. And the whole idea is to help people understand and apply AI by showing them how it works and talking about it. So it's not a product demo, it's an educational demonstration. It's bringing in the people who know what they're doing, who build this stuff every day, who consult on it, who can actually help all of us just better understand how it actually works. Because our feeling is once you know how it works, then you can much better find the use cases and applications within your own organization. So Cal, if you want to take us to the next slide, this is the topic for today. And this is a really cool topic. And I don't think it's the thing most marketers first ponder when they think about AI. You don't understand that bias goes into it and the importance of data and how this all plays in building AI. And you kind of, maybe this is a checklist item a year or two down the road. But our belief is it's fundamental to day one, that when you even are starting to think about piloting AI projects, you need to understand what goes into making AI function. And Cal is one of the best in the industry at making this stuff make sense. Not only is he a brilliant data scientist and AI researcher, but he's actually able to explain in common terms that we can all understand. And so Cal's, presented at our first MACON conference. They're a partner of the Institute and a supporter of the conference and a longtime friend. And Cal's got actually a certification course in our AI Academy online education platform on data and AI. So with that, Cal, why don't you jump to the next slide with the introductions? So I'm Paul Raitzer, founder and CEO of the Institute. And this is Al-Dhubaib, our guest today. Cal, thank you so much for everything you do for the community, but for being a part of this event today as well.
Absolutely, it's my pleasure.
You want to, take a moment, tell us a little bit about Pandata and what you do there, and kind of, the focus of that organization, and then we can talk about some of our other partners as well.
For sure. So Pandata, at its core, we're a consulting practice, and we help organizations design and develop AI and machine learning powered solutions. And we're specifically focused on trusted AI. So no black box, transparent, human first, and equitable. And we're going to talk a little bit more about why that's a growing and important trend starting on day one in your journey to AI.
Nice. So Pandata is one of our 6 presenters. If you want to jump to the next one, Cal.
Sure thing.
So this is the agenda. So yesterday we did automation of advertising with Seltra. It was really cool. If you missed that one, they're all going to be available on demand. We'll send out links and you'll be able to watch all of these sessions. But that one, we had a great presentation around how you can create one ad and then automate the generation of thousands of variations to fix sizes and colors. And it was really cool. And they provided a roadmap of where Seltra's technology is going. So again, if you're in the ad space creating digital ads, whether it's dozens of variations or thousands in the case of the big enterprises, that kind of tech was really cool. And Gazelle did an awesome job of actually explaining how it worked for us. So today we're going to talk about ethical AI-powered marketing strategy. Tomorrow, Lilt is going to talk about localization, the ability to take one piece of content and localize it to tons of markets, translation, geographically, personalization. And then next week, we've got Persado, Market Muse, and Drift. So really just a great lineup. If you want to jump to the next one, Cal, we'll do a couple of housekeeping items. So we will leave time for Q&A. So if you have questions, go ahead and drop them in. I'll be watching that as Cal's presenting. And if there's something urgent, we'll jump in and talk about it in the moment. Otherwise, I'll curate it at the end. If you need any help, we have our team available on chat, so they'll do that. There's a hashtag. The on-demand information, probably within 48 hours, we'll have that out. And then as the other ones happen, we'll add those videos to that on-demand page. So we're just going to create a single page you can go into and get access to all 6 of these when they're done. And then if you didn't sign up for the other ones and you want to do them live, you can go to that bit.ly/more AI in action, and that will actually take you back to the registration page, and you'll be able to register for the live sessions that are coming up if you didn't already. And with that, I'm going to get out of Cal's way and hang out a little bit and listen in like the rest of you. So Cal, take it away.
Awesome. Thank you so much, Paul, for that great intro. I'm still never shocked about, in fact, in spite of AI becoming more mainstream over the past few years, there's still this question of, is it really AI? And it's almost like there's this pressure from the investment community and the growing number of startups that are incorporating artificial intelligence into their products, their services, their platforms, to call something AI. And I get asked this quite a bit, and I'm not sure if you've seen this trend too or want to comment on this real quick, but figure it's a great way to kick this off.
Yeah, there's always that joke, like put a .ai in your domain name and you can raise an extra $10 million. Like it's just, yeah, there's definitely pressure on the startups at least to claim AI. And in a lot of cases, they're very, very early in the development of real AI technology.
Absolutely. So, this really comes down to a very simple definition. We tend to call things that we don't quite understand AI. And it's funny, if you think about it, autocomplete on our phones was something that was novel 5 years ago. And at that time, we called it AI. And now, question mark, is it really AI? So humans, we excel at performing under a variety of conditions. If you're a customer experience agent, you don't need to have a whole list of vocabulary or words to say, oh, this customer is upset. And traditionally, the older approaches to looking at things like that, you'd have to hard code. If there's a negative word like I'm frustrated, or it didn't fit, or it didn't work, you'd have this bank of things, and you'd start to score conversations, and it'd almost be rules driven. AI talks about something a little bit different. It's the ability to generalize, the ability to take a pattern that you've observed before and apply it to something else. I bring it down to these three criteria. Artificial intelligence is essentially software that excels at recognizing and reacting to complex patterns at scale. It has the ability to improve its ability to recognize and update these rules it's learning over time, and it's usually applied to human-like tasks. And what I mean when I say that is it understanding or comprehending language? Is it creating novel recommendations? Is it acting like a subject matter expert system, or categorizing patterns that might assist in decision-making? And I put this not AI list over here just to make a point. The joke that I usually get from data scientists now is, well, is a regression model AI? And the answer is it really depends, right? Are you building a regression model that's really basic and telling you that, for every square foot extra in a home, the dollar value goes up by, X $100, for example? That's a model for insights. And I don't know whether we could justify that as AI. But if you build a pretty powerful regression model that's used in sentiment analysis, and it has a really high degree of accuracy, and it's based on a vocabulary of hundreds of thousands of words, and you're updating it over time, that's technically AI. So I want to challenge the audience as you hear about these things. It's not about the modeling. It's not about the techniques. It's not about the approaches. It's about the outcomes. Is it a piece of software that has the ability to generalize, to recognize and react to complex patterns at scale? Does it have the ability to improve how it recognizes those patterns over time? And is it being applied to human-like tasks?
Yeah, and Cal, jump in for a second, because somebody actually asked a great question related to this already. Is is natural language processing learning as they go along? Is that only for ML? And that's, what we always say is, like, machine learning is, what is so fantastic about that is the definition is very literal. So machine learning is the primary subset of AI, and it literally means that the machine, the collection of software and hardware, is learning as it goes. And that's what you've kind of highlighted in these bullet points here, is it actually gets better and smarter on its own. Now, natural language processing, which Cal is going to talk about, the ability to tank language, process what it's saying, understand it, apply sentiment analysis to it, that isn't necessarily machine learning, or the machine learning is a layer that actually lets that get smarter as it's doing what it does.
Machine learning is essentially the process with which you're creating these models, and the models in action, that's AI.
Yeah.
And modeling and machine learning is just one tool in the tool belt here. So I'm going to talk really quick about what's changed over the past 18 months. I get asked this a lot. And as the whole world has shifted to digital, we've seen a handful of things that have accelerated and changed the game in the AI world. First, we're seeing the acceleration of digital adoption. So the pandemic has disrupted industries like banking, retail, traditional brick and mortar stores, and it's forced folks that were initially hesitant to adopt online and adopt certain sets of mobile and online behavior to get there sooner. And simultaneously, what that has done is it's actually changed assumptions that were initially used in some pretty common models to do things like lead forecasting, behavior analysis, revenue forecasting, et cetera. So COVID broke the models. These two things together have forced organizations to get really serious about using AI. When they were using models just for insights, like we were just talking about, regression, just for the sake of regression, instead of actually building more intelligent models that can generalize and react to things over time, this has forced organizations to challenge their assumptions. And it's also forced organizations to look to AI to enable some of these key processes. And finally, one of the most exciting changes that's happened over the last 18 months is what I refer to as AI design building blocks. And so when I say that, I mean the ability to leverage natural language, image, audio, video, and build intelligent applications around that used to be exclusively the domain of big tech companies. You'd need teams of data scientists, lots of code, lots of data. And today there exists a plethora of pre-trained models that exist out there. There are no-code building blocks and platforms that data scientists can use on small agile teams to really build next generation intelligent systems around a whole variety of new data sets. And that just wasn't possible before. So there's a lot of opportunity now to build these things that just didn't exist 18 months ago pre-pandemic.
As an example, Mike Kaput, our chief content officer, just published a blog post that went out in yesterday's newsletter for Marketing Institute, how he wrote a 650-word blog post with the machine, 100% with the machine. And he was using a technology called Hyperwrite that literally just recommends the next line and you select it. And as you're selecting, it literally builds the entire thing. So that's that whole no code idea. We took GPT-3 technology that someone else bundled into a user interface that was functional to a marketer with no coding ability and was able to actually create a piece of content using that language generation technology that 18 months ago wasn't possible.
So what goes hand in hand with what you just said, Paul, is I see this and I hear this all the time. One of the biggest objections is, well, our data isn't quite ready, or our data isn't quality enough to be able to build these things. A couple of years ago, if you were to look at the O'Reilly State of AI Industry Report, it polled organizations on what percent of them were actually deploying AI in production versus which ones were considering or not even ready to start that journey. And in 2019, it was about 20% or 30% of organizations were in the piloting stage. Very few had actually gotten into models in production. Now, fast forward with all these changes that have happened, and as of 2021, a lot of these organizations have now reached maturity, and they're in production, but they're hitting some issues with data availability, model reliability, et cetera. And so this is, if you look at the latest report now, what people are saying is the biggest barrier to adopting and deploying AI at scale isn't access to talent. It isn't the organizational culture required to adopt and deploy these systems. Those key factors have changed. But what most people are citing today as a barrier for deploying and adopting AI is either access to the right data, sufficient quality of data, and a key game changer is with these AI design building blocks that is becoming less and less of a hurdle. One of the things I'm going to talk about today is the concept of few-shot learning or transfer learning, where you're able to take these models that have already been trained, like a GPT-3, for example, and tweak it and refine it on a smaller set of data that you actually own to get into production. So now the game isn't do you have a tremendous amount of data, or you need this tremendous amount of data to get started? Do you have the right data, or can you identify within the data that you have the right data to get started? That being said, I'm going to jump right into a couple of case studies, because AI in action, what better way to learn about AI than to talk about some examples of how we've used this? So this example here, we were working with a Fortune 500 manufacturing organization that was dealing with quality control at scale. Most people by now have received some sort of survey, whether it's by text or email, after interacting with a vendor. On a scale from 1 to 10, how likely are you to recommend? And marketers are probably familiar with Net Promoter Score as a concept. What was happening here was there was a lot of qualitative feedback, because the second question that gets asked in the survey is, well, why? Or what can we improve? So they had accumulated over 60,000 comments. This was increasing to a rate of 8,000 comments a month, a quarter of which were in a foreign language. And I don't care how big your team is, it's near impossible to synthesize that level of insight just with humans alone. And part of what makes language so difficult for AI is that there's a lot of contradictions here. So if you look at this example review, and you'll see a lot of animals in my presentation because I love cats, but they say it's great at navigating floors, but it's too fast. Is fast a positive or a negative attribute? Is too fast a positive or a negative attribute? Language is complex and sometimes confusing, and so there's sometimes limitations to being able to automate traditional rules to solve for this. So here are some things that we encountered. In these 60,000 comments, labels didn't exist. If you were to just scrape all of the comments that you have, if you're an Amazon retailer, for example, across all of your products, they're not going to be pre-categorized. If you're pulling them from a survey system, unless you've been really diligent about having a human review each and every one, chances are your qualitative data or your customer feedback data isn't labeled. There are a lot of interesting.
Can you stop for 1 second and just explain label? Because as a data scientist, I know you deal with it day in and day out, but label, some people might not know what it means related to data to label something.
Oh, that's a great question, Paul. So label is essentially you have something categorized. You have it checked in your database. You have this comment, and somebody goes in and says, this comment was designated as a complaint about shipping or a complaint about customer service response. And in the data science world, we treat that as a label. A label is a great way for us to be able to teach a model how to recognize. So we have this label and we have an example of what that label looks like, and that's the text of the comment.
So in computer vision, it could be labeling photos as like automatically saying this is a beach with a ball, with water, with whatever, and rather than humans doing it, the machine does it.
Correct. So in most cases, when you have these qualitative data sets, labels don't exist, or if they exist, maybe they're not the right labels. So there's a lot of questions there. Two, I just talked about AI design building blocks. Now, the thing is, if you just take one of these models, there's a lot of topic models that exist out there that can be used for this. They might not be specific enough. And for example, when we tested these on our client, it would tell us that it was about manufacturing. And it's like, well, no kidding. It's a manufacturing company. And especially with the rise of changes in their business model over time, as we've continued to work with them and the shifts in response to the pandemic, the nature of the feedback has changed drastically. And this brings up a really good question of, is AI appropriate? And if so, what do we want to use AI to solve for? One, can we reduce the time it takes to label, or the amount of complexity required to create these labels? Because having the right labels and the right data is key to building accurate systems. Two, can we recognize specific business challenges that are not just generic categories, that actually are actionable for the customer experience team to make changes around? And finally, can we summarize and synthesize these key issues efficiently? So instead of reading 100 comments, maybe you just need to read 2 or 3. And there's a lot of advances that have been happening lately with natural language summarization. So what we did,
real quick, to like give people context, not only is it these text comments that you're talking about, but so many of us have call center data that's going unused. All this data is just sitting there, and the same principles he's talking about can be applied to labeling text or voice data that can then, kind of get turned into this too.
Absolutely. So the recipe that we followed here was one, can we use few-shot learning to convey human expertise onto this massive amount of data? And what's really cool about few-shot learning is it's essentially you can take one of these very sophisticated models like GPT-3 that's very good at generating content and give it a few examples of what good looks like, and it learns to refine its model based on what you're giving it. So we actually are able to tell it, hey, we want to find things about finding information online. That's a category. Follow-up time is another category. Website performance is another category. And it goes and it hunts and it finds comments that it thinks belongs to those concepts based on what it's been exposed to in the past. The next step in this process is where we now take human expertise. Instead of giving them 60,000 comments to label, we dealt with a few hundred. And what we did a clever experiment here that I'll talk a little bit more about in a bit, but each comment got reviewed by at least 3 different customer experience specialists, because what we were looking at is consistency. So we wanted the humans to either say, yes, that was the right label. No, this wasn't the right label. This is what it should have been. And we use that ability to then refine the model and deploy it at scale to all 60,000 comments. We actually got to 90% accuracy here, which is pretty impressive as far as categorization goes. And we're now continuing to get feedback on this model over time. Something to take note of here is, when is AI work and when does it not work so well? AI can only work when you generally arrive at consensus amongst equally trained human experts. And they don't have to be rocket scientists. We can talk about customer experience specialists being equally trained in how they categorize and handle issues. So this top chart over here shows, with respect to each of the feedback categories we were looking at, what % of the time did all 3 humans agree that that comment belonged to that category? So I'm just going to go to the next one to get the labels here. When it was a comment about a representative, they had almost 100% agreement. Yes, that was definitely about a representative. Versus self-service issues and customer relationship issues, they weren't agreeing all the time that that category was the right category. Now, what you see at the bottom is the accuracy of the model at recognizing those topics in action. And so there's a really interesting takeaway here about, do human experts agree? The first few, you can kind of see the model was really good at. The last 2, the model was less good at. So whenever you don't have clear, consistent definitions or processes internally, chances are you might have to do some work there before AI makes sense.
One other practical example, we did a consulting gig a couple of years ago for a healthcare company, and they had thousands of articles online. So this is really relevant if you create content or are involved in the content production of your company. And they had dozens of writers and editors who could tag the content based on a multi-thousand word taxonomy. So I write a post about knee injuries, and then I, as the writer, decide knee injury is a category, ACL injury is a category, and I'm picking the categories and automatically or manually tagging this. And what we found was there was no consistency. And so the idea there was, take your best editors, take the 2-3 best editors, how they handle tagging, teach the machine to tag like your best editors, and then it can learn over time. But your current tagging system is literally useless. You're spending thousands of hours a year doing this, and it's not actually going to be representative moving forward or useful. And so that's an example, again, that's very relevant to everybody. We probably all tag our blog posts when we publish them, but is everybody doing it differently? Could a machine even come in and learn how to tag it? Probably not, unless there's that consistent process.
Absolutely. So, the outcomes here are pretty exciting. One, we were able to increase trust in qualitative data. An interesting outcome of providing this organization with the insights of your customer experience specialists aren't on the same page with defining these issues. We actually gave them the opportunity to create a better taxonomy and a better process that, Paul, to your point, increased their capacity to tag and archive and organize things. They were able to react more quickly to changes in customer feedback and emerging topics as things changed over time. And what was really cool is their net promoter score actually increased by 20% on average over the course of the 2-year period. And that's a pretty impressive shift for a Fortune 500 organization.
Somebody got a raise from that.
It certainly wasn't us. So, you talked a little bit about applying this to the call center. I just want to, elaborate on the scale of the missed opportunity here if you're not yet taking advantage of your call center. With only 10,000 calls, averaging 5 minutes, 5 to 6 minutes a call, that's 1,000 hours of your customers telling you exactly what they need. That is easily 100x the amount of information that was contained in those 60,000 comments, for example. Hands down, you have significantly more insight and more immediate insight from your customers and what they need and what they want and what they're frustrated with, relative to any other qualitative source that you have access to. So we're now working on applying a lot of these same principles now, but to voice. Moving on to this next use case over here, has to do a little bit more with lead scoring. And this was actually with a healthcare IT company. They partner with insurance organizations to identify members that could get additional subsidies from the Medicare, for example. And if you want to apply this a little bit more generally, think of this as a really, really, really sophisticated lead generation model, where you have a high cost of qualifying, but also a high lifetime value of your customers. So they had over 30 million patient lives across all the different insurers that they worked with. Their team sends out mailings. And actually, let me just describe this a little bit better with a visual here. It starts with the insurance companies. So if you imagine that on the left with some data feeds, there's some rules that process which patients they want to mail. They send those out to the patients who then phone in and say, hey, I got this. I think I might qualify. Now, this is where things start getting a little bit more complicated. You have a lot of different reviewers helping these patients through the application process, qualifying them or disqualifying them, and ultimately moving them on to a judicial approval process, where a judge is actually in charge of approving or denying that case. Now, in theory, you would have consistent decision-making, but the reality is different judges interpret borderline cases differently. And there's a lot of nuance in decision-making across the thousands of regions and zip codes that this organization covers. And this is where AI starts getting really interesting, right? So we want to talk about, why does it matter? Why does AI make sense here? One, the rules are constantly changing. The human decision-making is very subjective, and you can keep track of a handful of rules if you're dealing with just one human, but if you're dealing with hundreds of human decision makers, now you might want to make a more localized, nuanced model. And medical coding and the features here are complex. Between all the zip codes, all the possible conditions or diagnoses that these patients could have, you're talking about tens of thousands of features. And this isn't unlike a lot of customer intelligence databases and customer data platforms that marketers now have access to build these sorts of models, right? We're talking about a lot of features, a lot of complexity here. So can we use AI, one, to predict these more nuanced human decisions? That was the key. It's not whether or not we think that this patient is a candidate, it's whether or not we think ultimately at the end the decision is going to be adjudicated. And then finally, can we explain that decision? Why? If we're finding patients that look different, can we explain why they look different? So diagnosis codes, just a really quick intro about why they're complex. They act like a tree, almost like a very complex product tree, where you might have a general category like diabetes patients. And then under that, it might be diabetes patients with progression stage, whatever. So the first step in this process was, instead of just treating this like a tree, could we maybe find things that were similar to each other, or reduce the complexity here by taking advantage of natural language processing and turn that into a feature into our model? So that actually helped us quite a bit here, being able to leverage this as an input. I'm going to jump forward to the results here. When we piloted this initially, they were originally converting 10% of all the patients they reached out to. Our model converted fewer than 2% after all this on the first run. The actual agents approving these patients and the ones in charge of sending out the mailings didn't trust these new models And when this client started to expand to new geographies, the fact that the decision-making was so nuanced on the geography level actually reduced the performance of the model even further. So it looked like a complete and utter failure. We were 5 times worse, even though in theory, AI has an ROI. And the reality is there's this resilience building process over time. We needed to dig into what was going on here. One thing we uncovered was these agents, their incentives and their bonuses actually depended on how many successful patients were adjudicated through the process. So all things being equal, when they saw patients that didn't look like the ones they were used to, they didn't trust them. They didn't follow through on them. So interpretability was actually a really important thing here. There's an ongoing education initiative that had to happen, but also improvements to the modeling process itself, where it's not just a black box. Hey, we think this is a good patient, but we think this is a good patient because. So taking those things into consideration and also generalizing the models a little bit to make them a little less sensitive to those geographies, we were able to increase monthly revenues by 13.5% to date. And this statistic continues to improve as we make ongoing refinements to this model. Whenever you are deploying AI in action, whether you are designing it and developing it yourself or adopting a solution that's a part of a platform, building resilience is a necessary step. So you hear the statistic that a lot of AI projects fail. They failed because the lessons learned and the pivots weren't applied. It just got killed because of the initial poor performance instead of understanding why. So really quick, here are the 3 things that you might want to think about as you're deploying models into production and what that might look like. 1, it might be a process change, and that has to do with change management. So are the incentives aligned, and is there trust in adopting the solution? It could be usability. And I'm going to talk a little bit more about what this means in terms of fairness in just a bit. But is the user experience frustrating? Is education necessary as a part of the adoption? And is interpretability not just a nice to have, but a need to have for success here? And finally, how often do you need to retrain your model, right? Is it something that's static? Is it something that you need to update assumptions on once per year? Or did an event like the pandemic happen that radically changed the assumptions under which this model was true need to change? And if you and your data science team are in charge of these things, great. You can take action on them. If not, you should absolutely be having conversations with your vendors about how they're handling these sorts of changes over time.
A really practical example there real quick, like if you're in the event marketing world, like we run an event, run a conference, the historical data is useless. Like we would have to retrain the models based on new data in the current environment, health environment, societal environment. So you're at the stage as an event organizer where you can't rely on old models and you actually have to go in and build new assumptions into these things.
Absolutely. So AI can go wrong. And sometimes when it goes wrong, the stakes are high and it's hard to spot how this might manifest itself. So over the past few years, there's been numerous examples, and I'm just going to go through a handful of illustrative ones. Amazon attempted to develop a resume filtering algorithm. They were trying to develop an AI that could help their recruiters, instead of sifting through thousands of resumes, identify the top candidates that they should reach out to. And they did this by saying, hey, let's look at our most successful applicants over the last 10 years. And we're going to train a model using label as candidate accepted, candidate rejected, right? Those are the labels. What ended up happening was this algorithm selected for more male applicants than female applicants. Well, the obvious thing was, let's blind the names. Let's make it gender blind. It continued to select more resumes by male applicants over female applicants. They noticed that under clubs, there were occasionally things like women's soccer club, women's chess club. Those things got penalized. So again, they made it blind to gendered terms. Guess what? It still selected more male resumes. And finally, they scrapped this when they realized that it was now not, it was picking up on gendered forms of writing, masculine writing versus feminine writing. And I'm not a psychology expert, but there's some really fascinating and very real nuance to the way gender presents itself in writing. So they realized that no matter how hard they tried, because the vast majority of positive examples in their history were male, it continued to perpetuate this bias. Joy Bolamini is a really cool researcher out of MIT, and she's well known for uncovering the fact that across almost all major facial recognition platforms, about 35% of them misidentify gender in darker skinned females, relative to 1% of misidentification rate in lighter skinned males. And why this matters is in terms of user experience. So something that we are really used to using now, especially if you have an Apple phone, is facial unlock. Imagine a significant portion of the population having a less frustrating or a more frustrating, less seamless experience with a piece of tech. And this is kind of disincluding them from the use of that technology. And finally, this last one happened about 2 years ago when this investigation uncovered a health system was delaying care to Black patients. Algorithms like this, by the way, are used to screen somewhere between 100 and 200 million patients a year across the US today. And the premise is simple. Readmissions is a major source of cost and reduced quality and outcomes in healthcare. Readmission is essentially you've been in the hospital for an inpatient procedure where you're getting surgery, you're being observed overnight, you're in the ER, and within 30 days or 45 days or however the hospital defines it, you are brought back for the same condition. So naturally, can we create algorithms to predict whether or not someone's at a greater risk for readmission? And what ended up happening here is that all things being equal, a Black patient and a white patient that were equally at risk, the white patient got a slightly higher risk score. And when they tried to dig into why this happened, it was because historically Black patients came from underserved neighborhoods and areas and had historic less access to care. And so the periodicity of how their care was represented over time in general across large populations led to the bias that was ultimately represented in the model. So the big takeaway here is these algorithms aren't being designed by sexist people. They're not being designed by racist people. And the intent certainly isn't there, but the unintended consequence happens as a result of data complexity and use case complexity. And to bring this home, we talked about sentiment analysis, and question to ask is, what if sentiment analysis is racist? And a study by the National Research Council of Canada uncovered across 200 different sentiment systems that there were actually significant amounts of racial bias. And the way they did this was they took these template sentences that had person and then some sort of feeling or some sort of description or action. And they swapped in where person was a list of traditionally African-American names and traditionally European American names. And what they found was the same sentence on average that had an African-American name was likely to have lower sentiment scores than that with a European American name. And it comes from the fact that when you think about how these systems are trained, they're trained based off of news articles that span decades or content across the internet. And if anyone's been on the internet lately, safe to say it's not a very pleasant place. So here's another really interesting example. The Allen AI Institute, AI2, is a nonprofit research institute. It was founded in 2014 by Microsoft co-founder Paul Allen. And their mission is essentially to conduct high impact AI research and engineering in service of the common good. With the emergence of technologies like GPT-3, Paul, we were talking about that earlier, and chatbots, there are more and more models and AI applications out there that are now generating content. It's fair to say a decent amount of people have now interacted with question answer systems where you ask the data, or you ask your report. So what they did here was they gave these QA systems some example sentences where they could search and find the answer. and a question that maybe wasn't related to the sentence. And the goal here wasn't to actually get a good answer. It was to understand what biases were programmed into or were incorporated into this model. So this first question, for example, the person over the swing is Angela, sitting by the slide is Patrick. And now this completely unrelated question, who is the entrepreneur? And these are some of the answers that really indicate the biases captured by these very complex models. I don't say this to scare you away, but I do say this to say that you need some sort of compass for understanding when you need extra diligence and when you need to do these extra spot checks. None of these use cases were ever designed with harm in mind, but if you were to imagine just this chart for a moment, where complexity of the data that you're using is on this y-axis over here, and complexity of the goal is on this x-axis over here. Complexity of the data can also be scale, size, but starting with spreadsheets, moving up to documents, and going all the way to the most complex forms, which is video that contains audio and moving imagery. And the complexity of the goal, on the other hand, that could be as simple as, hey, I want to detect, is this here, is this not here, to as complex as creating novel responses. When you are above that orange line, it gets harder and more subjective to define data quality and harder and more subjective to define bias. And this is where you really want to start asking questions.
That's pretty fascinating. When I saw that slide before, and I didn't connect the dots on what it was representing, but now that you just explained it, it makes total sense, because the complexity of the AI needed to do the top level, the data complexity is much more advanced, and the risk of it being wrong becomes much greater. Whereas we're just doing internal measurements and stuff, like there isn't that much harm that can be done to different stakeholders. But as you go further to the right, the harm potential becomes much greater.
Absolutely. So speaking of cats, and I don't know if you can see the picture, apparently mine decided to, yeah, they knew cats were coming. I've showed this slide before, and I just want to talk about how this happens. How does bias get encapsulated in models? And if we were to imagine a toy example where all we fed a model was these pictures of squirrels on the left and pictures of these cats on the right. Any guesses in the chat as to how this model might learn to differentiate between the cats and the squirrels?
What would the machine look at that would tell it something is a cat or something is a squirrel?
Yeah.
Grass versus floor, we've got hunting versus fleeing, size, grass, bushy tail. These are all good.
Cool. Yeah, these are all fun. So
tail size, voice.
Voice, yeah.
My dogs would chase both.
I've seen my favorite answer so far to this slide is skateboards. Clearly, cats are known for their skateboarding skills. So just to cut to the chase here, the difference between these that a model might pick up most likely would be the presence or lack of presence of grass. As humans, what we're doing is we're bringing prior experiences to this. We understand a scenery, we're segmenting it out, we're doing some things, we recognize live objects versus static objects. Versus a model, it's going to look for the easiest, most common way to differentiate between two sets of things. And in this case, there's an overwhelming amount of green on one side and not a lot of green on the other side. So this model is going to say, okay, that is the easiest way to tell the difference between these two with 100% accuracy. When I see grass, it's definitely a squirrel. When I don't see grass, it's definitely a cat. And you can see with this analogy how that might scale to human bias, or examples in a data set where really difference between two groups isn't what a human might perceive it to be, but introducing some element of bias. So there's this notion of the virtuous cycle of AI solutions that was popularized by Andrew Ng. And this is generally presented in context of products, but it also applies to internal solutions where you're using AI. You initially try to get some data to build a better model that results in a more efficient process. And as that process is executed, you have more observations, more human feedback over time about good decisions and bad decisions. And so you're collecting more data, and that leads to better models. This same process and this same cycle, if you have bias, negative bias in your models, can actually amplify the risk. And so you're creating more biased data that's creating less fair models that's resulting in less fair decisions, like the example with the white and black patients, that then in turn reduces access to care and creates even less fair models. And this is something that you want to be thinking about, especially as you move from piloting AI to actually managing and monitoring models and AI solutions in production. And this isn't just about avoiding risk. The business case for ethical AI is also good for your business. So the Capgemini Research Institute does a really cool study focused on AI ethics, where they're looking at consumer attitudes with respect to the use of AI technologies, and more specifically, the use of ethical AI technologies. So consumers are more likely to purchase more, share positive experiences, and place higher trust in a company that is perceived as applying and designing ethical AI solutions. Conversely, 34% of customers would completely stop interacting with a company if they perceived an issue that was the result of bias. And Paul, this goes back to the conversation with Tesla and the self-driving cars we had at the start of this chat, right? There's very little tolerance for AI going wrong. When it works really well, but all it takes is that one negative encounter and you go, nope, not for me.
Don't trust it all of a sudden.
So gone are the days where AI is just the domain of data scientists and data science teams. If there's one plea to all the marketers here on the webinar today, is that it's your job to get involved in these conversations. It's your job to ask these questions. And data science and AI teams can no longer consist exclusively of data scientists. So there's a lot of different definitions to what ethical AI entails, but fundamentally you want to be asking yourself about these 4 key tenets. Is it fair and is it inclusive, right? Is it potentially a use case that results in bias? Or is there a subset of the population that might have a different experience with your solution or your models? 2, is it transparent and explainable? There are a lot of black box models that exist out there, and a black box model is one that says, hey, I'm really good at predicting things, but because I'm so complex, I can't tell you why I've predicted what I've predicted. Are your models transparent and explainable? Can you audit them over time and go back and uncover why a model yielded the decision that it yielded? 3, is it privacy preserving? So especially as more laws like GDPR come out, and regulation is expanding to US states now in terms of data privacy and protection. Are your models privacy preserving or compromising aspects of privacy? And finally, this last bucket, this seems like a no-brainer, but are you really using AI to maximize human value? I sometimes see a misconception that AI is all about automation. We want to automate everything. We want to automate all the complex tasks. And the reality is, companies that have embraced this notion of AI plus humans are the ones that have benefited the most from deploying AI in action. There's a lot of these shiny use cases of self-driving cars now and automated chatbots, but behind the scenes, the vast majority of AI in action is really all about augmenting human decision makers. Some of the most brilliant chat experiences now consist of parts of it automated by a chatbot that then hands over to a human agent when it reaches a point where it now warrants that nuanced interaction. So AI is more about augmenting humans and enabling them to maximize the value that they deliver. So I'm just going to end on that note. Ethical AI starts with humans, and it rests on a foundation of trust.
That's a good way to end it. We do have, we'll jump through these last couple slides real quick, Cal, and then we'll jump into some questions. So if you're not familiar with Marketing AI Institute, it's your first time with us, you can learn more. There's blog, there's beginner's guide, there's online courses, there's all kinds of resources available at those 2 sites. But the next one, Cal, is the Marketing AI conference. And so Pandata will be there. We have more than 20 speakers participating, some incredible sessions. So if you haven't registered for the virtual event yet on September 13th and 14th, I definitely encourage you to do that. There's a live option, and then there's an all access option. But there's a special code here for AI in Action 25 to save 25% on that event. And with that, let's take a few questions. We definitely had some coming in as we were going.
Cool. So before the questions, just a quick shout out. If you want to have more conversations about trusted AI and continue these conversations, please check us out at Macon. But also a quick plug, we're in the process of launching a really exciting digest called Voices of Trusted AI. If you want to stay up to date, check out our website and subscribe to stay up to date on bite-sized insights about how this landscape is changing over time.
Okay, so my first question is, what is Voices of Trusted AI?
Oh, I love that. So, I'm going to stop sharing here for a bit, but Voices of Trusted AI, something that I've observed is there's a lot of growing examples of AI gone wrong. Yet there's not a lot of clear sources to stay up to date on what's changing or practical ways to deal with this. And as an expert in the field and talking to other experts in this field, we have to go all over. We're staying up to date with all the latest business journals, all the latest research, and it's really hard to understand what's happening, what's changing, and why it matters. And so we wanted to set out to solve that challenge at Pandata by creating one easy go-to source. If any of you have checked out the Morning Brew, get all your digests in 5 minutes, but focused once a month on what's happening in the trusted AI space.
Nice. Well, I will be subscribing. All right, so let's get into these questions. So we've got, how do organizations decide to use annotation platforms like Figure 8 or Append to label their data? Do a lot of companies annotate label in-house, or does it depend on the use case?
That's a great question. And actually, when I was bringing up this point earlier in the presentation about access to data, it's actually becoming a growing and common practice to work with these organizations that have vetted processes for creating new data sets, creating labels for data sets, and also having quality control around bias and standards for how these data sets are created. Honestly, it depends on the complexity of the use case, right? Are you talking about things where you have subject matter expertise in-house, and it's a matter of like that natural language processing example we talked about, where you're labeling a few hundred things? It doesn't need an outside engagement. Now, you're labeling tens of thousands of images at scale. Chances are you don't have the pre-existing people, infrastructure, or resources to support that. And so that's when it makes sense to start reaching to those outside platforms and vendors that specialize in curating these data sets.
Like Facebook's a great example. They use lots of manual labor to do tagging of videos and images online to try and prevent things from appearing that they wouldn't otherwise want to appear. And so they use AI to do that, but they use lots and lots of humans to do that too, which is a very thankless job, because they have to see a lot of things that most of us would not want to see in order to make it not appear there anymore. What percentage accuracy do you look for in a model before putting it into production?
That depends on the use case. So it's a really good question too. When we talk about models, there's a lot of different ways of qualifying accuracy. Two of the most common ones are precision and recall. And just to define this simply in English, what that means is if you're trying to detect, for example, all the comments that have to do with shipping time, for example, in a bucket. If there are 100 comments that exist, period, like if a human were to manually go through all of them and there are only 100, of those 100, how many is your model finding? If you're finding 80, you have 80% of all the actual things that you've actually found. That's one notion of accuracy. Then there's the flip side of that of everything your model says is related to shipping. How often is it right? And there's a trade-off there. So if you're talking about finding feedback, it may be better for you to have better precision, where, for example, if you're finding only half of all the things that have to do with shipping, but everything you find that your model finds is absolutely relating to shipping and you don't have noise in there. You're increasing trust in the system. There may be situations where it's the flip side. It's okay if you're not as good at when you say it's related to shipping, it's shipping. That's really common in healthcare, for example. So if you're screening for cancer, it's better to annoy a patient and say, we think you might have cancer, come in for extra screening, than it is to actually miss a case of cancer. So there's a cost associated with each of these notions of accuracy. And it really depends on what matters to your specific business case, right? Is it something that's an inconvenience, or is it a missed opportunity cost? And what's the dollar value on each side? Once it reaches an acceptable threshold where it makes sense for business decision-making, then it's good to go.
And as a non-data scientist, non-machine learning engineer myself, who's taken some machine learning courses, my interpretation when it comes to this stuff is that's what you ask the data scientists. That if you're putting a model into play, they're the ones that are able to assess any potential harm, what the right levels are that you want to look for in terms of accuracy, because they can assess on a case-by-case basis what is the best. And so that's when it's like, I don't think marketers are going to be the ones deciding what levels to set these things at and how to tune them.
Sure.
You get into the more complex use cases. That's why people like Cal are building great businesses. There's demand for that kind of expertise.
Well, I mean, just a point to extend that thought, Paul, is this notion of AI literacy. That's where marketers need to get educated, right? Know to ask the question, know when to reach out to a data scientist. And that is a key point to take away from here.
There's just a comment here I thought was really good, and we'll probably wrap up here. There's some other great questions, and we'll maybe address those in like a future blog post or follow up with people. But someone had said AI is merely a tool, an important one, but at the end of the day, just another tool. It's actually something I fundamentally agree with. The way we teach AI is it's just smarter technology. Like, you're going to buy email marketing software, you're going to buy CRM software, you're going to buy social media software, you're going to run campaigns to generate leads, and don't buy software that doesn't have AI infused in it, because it can make you better at your job and it can make the outcomes better. So all we're trying to do is tell people there is smarter technologies, smarter processes to do what you do every day, and maybe do some things like analyzing 60,000 comments that you just wouldn't even do otherwise. AI is what makes that possible. It's the collection of tools and technologies that enable you to be a smarter marketer. And so, yes, it is really just a tool when you want to boil it down to it. That is not incorrect, but it is a fundamentally transformative technology that, with all its applications across language and vision and prediction, can completely change the way marketing functions and can change the way business and society function, and is changing those things. So it's like, that's all this is about, is like, be curious enough to come to the next session, or to go read, what Cal's written, or to subscribe to that newsletter. Be the one in your company or in your peer group that actually takes the initiative to learn this stuff, because you can get way out ahead of your peers. So I guess that's my soapbox final thought for the day. Cal, do you have a final thought that we'll wrap up with?
I can't stress that enough. This notion of AI literacy, being able to navigate these concepts, explain them to your organization, and know when to reach for expert help, is one of the most important skills you can equip yourself with to be able to navigate the changes AI will introduce to the business landscape. So one last plug, check out the trusted voices of Trusted AI Digest on our website. And I really look forward to continuing this conversation at MACON.
Thank you so much, Cal. It's always great to have you on. And thank you to everybody who attended. We hope we'll see you at the next one. Have a great day.